So this is just a step further for applications of growth and decay. We have two different formulas. The first one is if you have compounded interest. So the ones that we have seen so far have been interest that's just yearly, so annual rates, but you could see different compounds. So the different types of examples that you could run into could be quarterly. So if you have interest that is compounded quarterly, that happens 4 times a year. You have 4 quarters in a year of school. You could have monthly, and so that's 12 times per year. You could also have daily, and so that would be 365. You do have to know quarterly, monthly, and daily, how many quarters in a year, months, and days. But as far as the formulas, they will be given to you. So the difference between this formula and the one that we've seen before is that we now have this N, so R over N, and then N times T. And so what that N stands for is how often it is, how many times it's compounded per year. So if it was compounded quarterly, then N would equal 4. If it was compounded monthly, N would be 12. If it was compounded daily, it would be 365. Obviously, if it were compounded just yearly, once per year, then N equals 1. So that's why in the examples we've seen before, we didn't worry about the N's because it would be R over 1 and then T times 1. The next formula that we'll see is growth and decay half-life. So you'll see a few examples discussing what half-life is, and that's just cutting things in half. And so A is your initial amount. The X represents your half-life rate. T represents your time. And then F of T is going to be your final amount. So we'll go through a few examples of that. So number 1, it says, suppose a certain car depreciates, meaning it's going to be decay. Cannot write that. Decay. At a rate of 20% per year. If the final value of the car after 5 years is $12,616, what was the original price? So it doesn't talk about being compounded quarterly, monthly, or daily. So I just assume that it is yearly, and it talks about 5 years. So I'm going to use the formula, the decay rate formula, which would be F of T equals A 1 minus R to the T. Then I'm going to plug in the values that they give me. So my R would be 0.2. So my R is 0.2. The final value is 12,616. So that's going to go here in my final answer. And then T, so time is 5. And then the question is asking me for my original price. So I'm trying to solve for A. So what I'm going to do is I'm going to plug in all of my values and get an original function. So I'm going to take 12,616 equals, I don't know what A is, 1 minus 0.20 because R is 0.2 to the 5th power. So you end up getting 1 minus 0.20 is 0.8 to the 5th power. Then I'm going to plug 0.8 to the 5th power in my calculator, and you get 0.32768. times A. Then I divide each side by 0.32768. And I get my final answer, which would be A equals 38,598 cents. So that means that my car started out at 38,000 and then depreciated to 12,000 after 5 years. That is very sad. Okay, number 2, the DFW Metroplex has a population of 4.5 million in the year 2000, and the population increases at a rate of 5% per year. Per year, again, annually, so we haven't seen anything with compounded just yet. We'll get to those examples in a minute. Just kind of a review. So it says, what is the projected population in 2015, which would mean that my time would be 15. So T would equal 15 because it starts out in 2000. It's increased, so that means that it's a growth. So I'm going to take my formula, F of T equals A 1 plus R to the T. I'm going to plug in what I already have. So I know that the population started at 4.5 million. So 4,500,000. You could also do 4.5 if you just were measuring it in millions. It increases at a rate of 5%, so R equals 0.05 to the T. Then I'm going to plug in T equals 15. So F of 15 equals 1.06 to the 15th power. And you should get 10,784,512. So in 2015, my new population would be around almost 11 million. Then it says, when in what year will the population exceed 13 million? So this is when I'm going to make my chart. And then population. We know that it has to be greater than 15. So I could try plugging in 16, 17. I'm just going to keep going until I end up exceeding 15 million. So in 2016, you end up getting 11.4 million. In 2017, you get 12.1 million. In 2018, you get 12.8 million. In 2019, you get 13.6 million. So it is in the year 2019 when I exceed 13 million. Okay, here we have a half-life question. So it says, find the amount of 30 milligrams of iodine, which has a half-life of 20 hours after 60 hours. So the important numbers that I have are 30, 20, and 60. My formula is F of T equals A times 1/2 to the X over T. So A is my initial amount, which would be 30. My half-life rate is 20 hours, and my total time is 60 hours. You have to make sure that X and T are the same units. So basically 20 hours out of 60 hours. If one were measured in minutes, then you'd need to convert something. So I'm going to go ahead and plug in f of t equals 30 times 1/2 to the 20 over 60. And you just plug that into your calculator. So once you plug that in to the third, you get 23.81, and then that would be measured in milligrams. Okay, the next one, it says find the amount of 200 milligrams of calcium, which has a half-life of 110 hours after 2 weeks. So my half-life is measured in hours. I need to convert my weeks, or my time, because this would be my X, T, and A. I need to convert my time into hours. So if I have 2 weeks, that means that I have 14 days, and there are 24 hours in a day. So in 2 weeks, I have a total of 336 hours. So make sure that you convert. The X and T are the same. So then I'm going to plug that into my formula. F of T equals A 1/2 to the X over T. My initial amount is 200. 1/2. My X would be 110. And now my total time is 336. So when I plug that in, you end up getting 159.4, and that will be measured in milligrams. Okay, number 5, it says, after how many days will 17 milligrams... Okay, so for this one, we're going to cross this one out. You will not be tested over this one. And we'll get to that next semester when we talk about logarithms, and it'll be fun. So then number 6, this is our last example when we're going to be talking about compounding. So it says, on the day you were born, your grandmother invests $1,000 at an annual interest rate of 3% compounded monthly. How much is your account on your 18th birthday? This could be true for some of you, so this would be a good way to figure that out. So it says compounded monthly. The formula is F of T equals your initial amount, 1 plus your rate over how much is compounded times how much is compounded times years. So how much time. So here we need to identify what we have. So we start out at $1,000. My interest rate is 3%, so 0.03. My compound is monthly, so there are 12 months in a year. And then on my 18th birthday, so 18 years have gone by. So I'm going to figure that out by plugging it in. So F of 18 equals 1,000, 1 plus 0.03 over 12 times, or raised to the 12 times 18. Then I'm going to just type that into my calculator. I can simplify. So if I take 1 plus 0.03 divided by 12, you end up getting 1.0025. And then 12 times 18 is 216. So when I plug that into my calculator, raised to the 216th power, you end up getting $1,714.85. That'd be a period, not a comma. So the only difference between that and the ones we did before is now we have the compounded monthly. So then on number 7, it says on question 6, how much is in your account if it's compounded quarterly and daily? So the only difference now is that I'm going to have a different N value. So for quarterly, my N would equal 4. For daily, my N would equal 365. So for quarterly, I'm going to plug in, still going to use 18. It would still be $1,000. 1 plus, then I have 0.03 over 4. Raise it to the 4 times 18. So everything stays the same except my ends. So when I plug that into my calculator, 1 plus 0.03 divided by 4, that would give me 1.0075. And then 4 times 18 gives me 72. So I plug in the entire thing to the 72nd power. I get 1,712.55. Then if it's compounded daily, same process, but now I use 365. So f of 18 equals 1,000, 1 plus 0.03 over 365, then 365 days times 18 years. So you get a really tiny decimal when you plug in this 1 plus 0.03 to 365. So I'm just going to plug in the entire thing into my calculator. And you get 1,715.97.